Skyward Sword definitely wasn't my favorite Zelda, but it did have its moments. In particular, I always thought the introduction to the Gate of Time was really cool. I've been wondering how they pulled this off since I first saw the cutscene over 10 years ago, so I thought I'd try to make the Gate of Time in Unity. I think it turned out pretty well, so today I'm going to share with you everything I learned while making this project. We'll start off with the models in Blender, and then we'll write some shaders and scripts in Unity to put everything together. As always, I'll be uploading all the finished files to GitHub, so make sure to check the link in the description. With that out of the way, let's get started. We're in a fresh Blender project, and what we're going to do is make all the models that we need. So that's going to include the first gear that Link touches. It's going to include all those rotating gears inside. And we're also going to make a sort of cover that's going to act as the background inside the Gate of Time. So to start off, let's go to Add Mesh Circle. And we're going to give him 24 vertices and a radius of 2. And then let's also rotate 90 degrees around the y-axis, and that's going to make it so it stands up. And let's go ahead and tab to go into edit mode, and then press F to fill in a face. And now what we're going to do is make the gear have some, I guess they're called spokes or something. Actually, first let's rotate it so the top and bottom of the circle are flat. So R to rotate. And then we're going to rotate, I think it's like 7.5 degrees. So you can just go down here and fill that in. I'm going to do negative 7.5. And that's going to make it so the bottom and top of the circle are flat. Then we're going to go back to edit mode and then edge select. And then we're just going to grab every other edge. So hold shift. And these are the edges that we're going to turn into the spokes of the gear. I'm just going to go around the circle, grab every other edge. And then now we're going to extrude them. Okay, so press E. And you'll notice they all sort of go in the same direction, which obviously isn't what we want for a gear. So go ahead and right click to just put them right back where we found them. And then I'm going to go up here and then this is for scaling, right? So I'm going to hit the 3D cursor. So now when we press S to scale, everything's going to scale inward or outward relative to this 3D cursor right here, the center of the world. So if I press S now and then scale outward, you'll notice that they all go outward from the center, which is what we want. So I'm going to scale to, let's see, I'm looking at the top of the spoke right there. So that's about 3 squares. So I'm going to do right about there. And then now what we're going to do is scale all of these edges inward relative to themselves, if that makes sense. So I'm going to go up here and select individual origins. So now when I scale, all of these spokes are going to scale relative to the middle of the edge. And I'm going to make it about that big. That looks pretty good. Okay, so now we have like a 2D representation of the gear. And I'm going to go ahead and turn on backface culling. And the reason you want to do this is because if you import a plane to Unity, it's automatically not going to show one of the faces like that. So this just helps make sure that everything looks consistent between Blender and Unity. Okay, so back to edit mode. Let's go ahead and extrude. So I'm going to go to face select, A to select everything, and then I'm going to look down the y-axis. And then press E to extrude, hold control, and then just go out horizontally for 5 squares, like that. And now that looks pretty good. What do we want to do now? Let's see. So the gear has kind of like a sort of portal thing in the middle. It's just like another circle that's inset inside the face of the gear. So select this face right here and then press I to inset and then scale down to about right there. That looks pretty good. So this is going to be the portal that Link runs into in that cutscene. Okay. So if you've ever done anything like this before, you probably know that this face has to have a different material than this face, because the outer ring of the gear is going to be like pink or purple or whatever that was. And then the inner gear is going to have some material that makes the portal effect. So what I'm going to do is press A to select everything. And then I'm going to go to Materials, New. And then I'm just going to call this like purple. It doesn't really matter. And then I'm going to change this to like a purple color or something. And then if we go to Material Preview, you can see the whole thing turns purple now. Probably wasn't the best color to choose because that's also the color something turns when it doesn't have a material, but whatever, it's fine. I'm just going to go with it. So let's make another material, New, and then I'm going to call this Portal. And then this color doesn't matter, it just needs to be different, so I'm going to leave it white. And then I'm going to hit Assign. So that's going to assign it to just this face, and you'll see that it turns white. Okay, perfect. So that's all the materials assigned. So let's go back to solid shading. And then object mode with the gear selected, I'm going to Control A, location, rotation, and scale. And that's just to keep everything consistent when we export to Unity. And now I'm going to go to File, Export, FBX. So if you haven't already, create a Unity project and make sure you know where the assets folder is, and you're going to save directly to that assets folder of that project. So I'm going to hit selected objects on the right hand side of the export menu, and I'm also going to scroll down to the bottom right and hit apply transform. I know you can't see this, but just look in the right tab and then make sure you check selected objects and apply transform. And then I'm also going to name this, I'll just call it portal gear .fbx. Okay, so go ahead and save that to your assets folder, and that should be it for the first gear. Now we're going to work on all of those blue gears that are inside the gate of time. So let's go to Add, Mesh, and Circle. And it's going to be 32 vertices, a radius of 4, and rotate around the y-axis 90 degrees again. And it's probably a bit bigger than you expected, but it'll make sense when we import it to Unity. So go to Edit Mode, and then F to fill in a face. So if you look at the footage, you can see that the blue gears that are inside are sort of like the inverse of the purple gear that's outside. So like this gear has spokes on the outside, but the blue gears have spokes on the inside. So we can actually do that pretty easily by doing a Boolean modifier. So back in edit mode, with this one selected, I'm going to, and you know, this is a good time to rename these. So double click on the first one and we'll call it portal gear. And then double click on this one and I'm going to call this inner gear, like that. So with inner gear selected, look down the y-axis, G to grab, and then just move it so it's hovering over this gear. And then what we're going to do is go to modifiers and add, and then we're going to use the Boolean modifier. So if I do difference and I select the portal gear, then wherever this portal gear is touching is going to cut a hole into this inner gear. So go ahead and apply. And then if we hide in portal gear, then we can see there's a gear-shaped hole in the middle. So then these spokes are going to be the spokes for the inner gear. Okay, and let's go ahead and move it back to where it was. And then now back in edit mode, face select, press A to select everything. And then we're going to extrude it out 5 squares, just like the other one. So hold Control, 2, 3, 4, 5. There we go, looks pretty good. And now what we want to do is do some UV unwrapping, and don't worry, it's not going to be that difficult. And that's just so we can put that blue texture on it that makes it look like it's being hit by the light. So we're going to go to UV editing, and then I'm going to slide this over, and let's look down the x-axis. And then we're going to press U to unwrap the UVs, and we're going to do a cube projection. So let's see. And we're actually missing some things from this UV here on the left. So I'm going to press A to select everything. Click on this side, press A to select everything. Look down the x-axis again. Now let's try the unwrap one more time. So U to unwrap, cube projection, and you can see now we have all these little things in the middle. And that's actually these faces that are inside the gear. So we're actually going to try and grab all of these. So go to Island Select up here, and then just kind of scroll through, select all these, and then press S to scale, and then we're just going to shrink them down right into the middle. And that's because we don't really need to worry about these. Okay, that looks pretty good. And now what we want to do is actually go to the texture paint panel. And right now this thing is bright pink because it doesn't have a texture on it. So, or a material, excuse me. So let's go here and then create a new image. And we'll call this, I don't know, blue light. Kind of what it's supposed to represent. And then it's going to be a 512 by 512 image. So 512, 512, hit OK. And then we have the image here, it's all black, but notice that it hasn't been transferred over to the gear, and that's because we haven't made a material for it yet. So go here to the material properties, and we're going to create a new material for inner gear, and we'll just call it inner gear, it doesn't really matter, material. And then we're going to go to emission, which means it doesn't need a light source. And then click this yellow button here, and then we're going to go to image texture, because we want our image here to be transferred onto the gear. And then if you go to this tab right here, you can select the image that we just made, blue light, and now it's completely black. And if I paint over this guy, you'll see that it gets transferred to the gear. And it looks like it's kind of sideways, like rotated a little bit, but it doesn't really matter. You'll see why that is. And what we want right now is kind of like an image where it's kind of bright in the middle and then it fades to the edges like that. So I did this before, and the radius that worked for me was 294 pixels up here. And then make sure your fall off is set to the first one right here. It should be already because that's the default. And then what we're going to do is try to align this cursor with the exact center of the image. So you can try to line it up with that line right there and that line right there. And it doesn't need to be perfect, but that looks pretty good to me. So just one left click and there we go. So now if you go back to layout and then look at material preview, you can see the center of the gear is pretty bright, and then the light kind of fades as it goes towards the edge of the gear. So it kind of makes it look like there's a light source in the middle. And that's basically it for this gear. So we're going to hit Control A, apply location and rotation and scale, and then go to File, Export, FBX, and then again go to that same asset folder. I'm just going to call this inner gear. And then again, hit selected objects and apply transform, and then export to your Unity project. And one more thing with this, let's go back to texture paint, and then we need to make sure to save this image. It's actually not going to get saved along with the material, so go to image, and you'll see it has a little asterisk right here. That means we haven't saved it yet. And then save as, and then same thing, just go to wherever your assets folder is in your new project, and you can just save it right there. I'm just going to save it as bluelight.png. And there we go. And lastly, we're going to make a giant cylinder to cover everything. And the idea behind this is when you look through the portal in the middle of the gear, you don't want to see whatever's behind it in your scene. So basically we just need something to cover it that covers every single side. So we're going to go to add, mesh, and cylinder. And we can leave it at 32 vertices. And then the radius is going to be 3. And then we're going to make a depth of 10 actually. And let's go ahead and rotate 90 degrees around the y-axis again. And let's go ahead and push him about like right there at the center of the world. That should be good. And I'm going to go ahead and hide inner gear. And then if we switch back to solid shading, what we can do now is, well, let me explain. So if I go into edit mode and then I hide this face right here, maybe H. If you look inside the cylinder, it's completely see-through, and that's because Blender and Unity are going to be getting rid of the back faces, which is the things that you don't normally see. So I'm going to hit Alt-H to bring that back. And what we can do is press A to select every face, go to Mesh, Normals, and Flip. And that's going to make it so that when you look at the cylinder, you can look inside it from every single angle, and then the other side is going to be opaque. So it's still see-through in Blender, but In Unity, it'll be completely solid, like you won't be able to see through it at all. And I think that's it actually. So what we're gonna do is select it and then Control A, location, rotation, and scale. And then we're going to export the FBX again. So go back to your Unity project, and then I'm gonna call it cover.fbx. And then again, limit to selected objects on the right, scroll down, and then apply transform and export. And there we go. That should be it for Unity. Did I say Unity? I'm in Blender. Okay, so here we are in Unity, and I've got a fresh project, and here is all of the things we made in Blender down here. And then all I've done is put a giant plane on the ground, and I turned off gizmos so that we don't need to look at them. So what we're going to do is grab the portal gear right here, and then it should be facing towards the -x direction. And then, let's see, I'm going to zero out all the positions, and then I'm going to raise it up to 6, and then I'm going to bring it forward towards the -x direction by 6. So I'm just going to put a -6 in the transform. And that looks pretty good. And then let's bring out one of the inner gears right here. So I'm going to put it at the exact same spot. So -6 and 6 and 0. And then you can see it fits pretty nicely in the gear right there. And then I'm going to move it back a bit to, I think, -5.5. It's pretty good. And then, yeah, it's just like just about touching the back of the gear. And then I'm going to move it up a little bit. And so now we have our first problem, because we need to, one, make it so that when we look through the middle of this gear, we can see the gears behind it. And 2, we need to make it so that if we're not looking through the portal, we don't see the rest of the gear out here. So what we're going to do is actually write a shader ourselves that makes use of the stencil buffer. So I talked about stencil buffers a lot in my antechamber video. So if you want a really thorough explanation, I'd recommend you check out that video, but I'll go over them briefly here as well. And the stencil buffer is really just an array of numbers equal to the size of the screen, right? So here I have an array that's size 1920 by 1080, and you can see that there's initially just a 0 everywhere in the stencil buffer. So there's a number for every single pixel, and it starts off as 0. So if we look at this example right here, I got a picture frame with a bunch of 1s inside the frame, and then there's this like blue monkey and red box behind it. So what's going on here is I added some code to the picture frame that tells it to turn transparent, and also put a bunch of 1s in the stencil buffer at whatever pixels that it touches. And then what I did is added some shader code to the monkey and the red box, and that code says only show these objects at places where the stencil buffer has the value 1. So the only places where the stencil buffer has the value 1, obviously, is going to be behind that transparent frame. And everywhere else, it's going to be 0. And you can see if you look in the Unity editor, the monkey is still there. It's just not being drawn to the screen because there's not a 1 in the stencil buffer at that location. Let's get down to writing some actual shader code now. So I'm going to right-click in our assets folder, create shader, unlit shader. And I'm going to call this portal. So this is the material that's going to go on the center of the gear right here. And there's 2 steps for this part. We need to turn it transparent, and we also need to have it right into the stencil buffer. So before we open that, I'm going to go ahead and create a material from the shader and then drop it onto the portal. And if we double click, should open up, and here we are in VS Code. And we're going to ignore most of the shader code here. And let's get started on transparency. So I explained how to do this better in my antechamber video, so I'm going to go kind of brief here. I'm just going to change the render type to transparent. And we're going to create a Q tag and then set that equal to the transparent Q. And this just tells it to render after the opaque objects. And then I'm going to write blend source alpha 1 minus source alpha, and this just tells Unity what to do with the alpha value that we give the object. And then what I'm going to do is write Z right off. And this is another step for the rendering process. It's kind of complicated because it uses the depth buffer. But basically it just tells objects behind the transparent objects that we still want to render them. And then lastly, we can go down here, and this is where the color for the pixel is returned. So we're going to grab that right before it gets returned, and then to access the alpha value, all we have to do is write call.a, and then we can set that equal to 0 because we want complete transparency. And that looks pretty good. So if we go back to Unity, the center of the gear turns completely transparent. All right, so next, let's create the shader for the inner gear. So I'm going to create another unlit shader. I'm going to call this inner gear. And then we'll create a material. Create material, and let's go ahead and drag that on the inner gear and open it up. So we're not going to have to worry about transparency with this one, but we are going to access the stencil block right here. So we're going to write stencil, curly braces, and I'm going to write ref1, and this just says put the value 1 into the variable ref, and then I'm going to write comp equal. And this is the stencil test part, and it's basically comparing the value in ref with whatever's in the stencil buffer at that pixel. So it's going to say if the value is equal to ref, then we're going to write the shader. If it's not equal to ref, then we're not going to write the shader. So let's Control S and go back to Unity and see what happens. And the gear disappears, and that's because nowhere in the stencil buffer is there the value 1. Everything is 0 right now. So there's no pixel where the gear is going to be drawn. So now let's go back to the portal shader, and we're going to create some places where the stencil value is 1. So I'm going to write stencil, and then ref1, and then I'm going to write comp always, and this just says don't worry about the stencil test. We're always going to pass this shader. And then I'm going to write pass replace. And what this is going to do is once the shader passes the stencil test, it's going to replace the value in the stencil buffer at that pixel with the value in ref, which is 1. So if we go back to Unity, we see that we still don't see the inner gear even when it's behind the portal. So what's the deal with that? Well, the reason is the portal shader has the Q transparent, while the inner gear has the Q opaque, even though it doesn't say it. So that means the inner gear is going to render before the portal, which means it's going to render before the value 1 is put into the stencil buffer. So to fix that, we can just write Q. Oops, I don't know what I did there. Q, and then set it equal to transparent plus 1. And this just means render right after the transparent Q. So if we go back to Unity now, we can see that the gear is showing behind this portal shader. And that's entirely due to the stencil buffer. And then before we say goodbye to these two shaders, let's make it so that we can see a texture on that inner gear. So what I'm going to do is click on the inner gear to expose it in the editor. And this is the material inner gear. And I'm going to drag this blue light texture into the texture slot. And now you can see that it's showing on our gear just like we made it in Blender. The problem is we want this to be blue because if it was just white and black, it would look kind of ugly. So I'm going to open that inner gear shader again. And let's create a new property that allows us to tint the shader. So I'm going to write tint here with an underscore. I don't know why that's the convention, but it is. And we're going to write tint color. And whatever you put in this string right here is going to show up in the Unity editor. And then the type is a color. And the default value is just going to be all ones. So that's RGB and alpha. And then when you declare a property up here, you need to declare it in the CG program down here. And this is going to be a float 4 because it has 4 things in it. So there we go. And then lastly, we need to actually have it interact with this color that we're returning. And it's pretty easy. All we have to do is multiply it on. So whatever color we set this tint is going to get multiplied on to the final color of the pixel. So if we go back to Unity, nothing changes, and that's because we haven't set the tint color. So you can see here we have this new tint color property, and it gives us this nice little color wheel. So I'm going to drag it around to kind of like a cyan color, and then total saturation. And that looks a little too green, so maybe slightly more cyan, and that looks pretty good. And let's see, what do we need now? So let's create another material from this inner gear material. And I'm going to call this unlit cover. And that's because this is going to go on the cover. So let's go ahead and drag that onto the scene. And remember, this is so that we don't see any of the background when we're looking through the portal. So I'm going to put this as x -6, y 6, z 0. That's pretty good. And then I think it's a little bit too shallow, so I'm going to increase the x value to 1.5. And then the y value, I'll do, I think, maybe 1.4 and z 1.4. And that's just because I don't think we got the dimensions quite right in Blender, but I'm too lazy to go back and change it. So let's go ahead and drag this cover material onto the cover. And let's see, maybe if I go over here, cover, there we go. And the whole thing turns completely white, and that's because it's an unlit shader with a tint color of white. And that's obviously not what we want. We want a black background, so let's go and change the tint color to black. And there we go. It looks like we're staring kind of into some weird abyss or something like that. And I think that's it for the shader. So what I'm going to do is actually drag this cover and then just put it into some folder somewhere else. Everything we're going to do here is going to deal with, whoop. Yeah, let's keep both, whatever. And everything we're going to do here is going to deal with things inside the scene editor. So we're actually not going to use these anymore. So you can just drag them off somewhere. And keep both. Keep both. And there we go. And I just realized we're going to do some more work on this inner gear shader. So don't hide that in a folder just yet. I'm going to keep it right here in the editor so we can use it later. And now comes the really boring part where we need to individually align every single inner gear to the right spot. And if you go back and look at the actual Gate of Time footage in the game, you can see that they make this sort of like spiral pattern that goes inwards and the gears get smaller and smaller. So I haven't thought of a good way to do this besides just literally editing the transforms of every single gear. So for example, if we took this inner gear here, I'm going to actually drag these down. So put these at the bottom of your hierarchy with the inner gear at the very bottom. And I'm going to drag this around and then move it about... okay, well, yeah, here's our first problem. This inner gear is actually a bit too small. And there's no way to get them all right just because they're all at different sizes. So I'm going to change Y and Z in the scale to 1.1 and 1.1. And then now if we drag this inner gear up to about, I think 7 is a good number, then that's actually what it looks like in the game. So what we can do is actually just duplicate this one. If I can find it, yeah, right there, duplicate. And now we have inner gear 1. And what I'm going to do is slide this backwards to just -5, like that. And then we're going to drag it up a little bit. And then we're going to decrease the scale as we get further and further back. So this one is just going to be 1, 1. And then we actually don't have to change the rotations, which is nice. And then you can see that if you look at the footage, this gear is kind of more to the right. And then the sort of... the edges of the spokes of the gears make this spiral that goes inwards. So you can try to line it up by doing the spokes right here. And instead of making you all sit through this as I individually adjust the gears, I'm going to skip ahead and just post the transforms of all of the gears to the screen. So you can go ahead and copy those into your project. And then we'll just skip ahead in the video to where all the gears are set up in the right position. So if you duplicated all the gears and you copied all the transforms into your scene, you should have something looking like this now. And before we get working on the scripts for the animation and rotation and all that, let's actually get the main camera in the right spot. So if I go ahead and turn on gizmos, you can see I have the camera right here and it's facing all the gears. So these are the positions and rotations I used in the transforms. And so if you press play, the camera will just be looking straight at the gears like that. So go ahead and put your camera in this position. Now that everything's set up, let's go ahead and start working on those rotation scripts. So I'm going to right click and create a C# script, and I'm going to call this gear rotate. And let's double click. Okay, let's double click. And here we are. Let's go ahead and delete these comments. And delete. And we're actually going to delete the update function, and we're going to replace it with something called a coroutine. So I'm going to write I enumerator. I'm going to spell it right, and I'm going to write rotate, parentheses, and here is our code block. And to call this function, we're just going to call it once from start. And I'm going to do start coroutine and rotate. And there we go. And end that in a semicolon. And this is giving me an error. And that's because an I enumerator has to return, well, it has to do a yield return, and we can just write null for now to make that go away. And it seems like there's a lot of confusion for how these coroutines work. So let's go through a brief explanation of what this actually is. So here's the script I made, and it's just going to walk a character forward a set amount every second. So if we look, we have this variable called counter, and in the update function, which is called every frame, we're going to add this small amount time.deltaTime to counter. And I'll talk more about this later, but time.deltaTime is just the time that has elapsed between the last frame being called and this frame being called. So then below that we have this if statement, and once the counter passes 1, we're going to move the transform forward by, I think, 1 meter basically, and then we're going to reset the counter to 0. So every second, the transform is going to move forward by this amount. And if we play that script in the Unity editor, you can see that it kind of just walks this monkey forward every second or so. Now let's look at this other function, which actually does the exact same thing, but with a coroutine. So in our start block, we have this thing that says start coroutine, walk forward, and then we have this function I enumerator, walk forward. And in here we have this while true statement, which means it's just going to run forever until the function is destroyed. And in that while block, we move the transform forward by that same vector 3.forward, and then we yield return a new wait for seconds 1. So you could probably guess, but that yield return is just going to pause the function for whatever seconds value we pass in this case 1 second. And then once that's up, it's going to return to the top of the while block, and then it's going to move that transform forward by the same amount again. So you might be wondering, if this does the exact same thing as the update function, well, what's the point? And the point is that 1, well, this is just a bit easier to understand. You don't have to have this counter variable that you're continuously updating with time.deltaTime. And 2, it's a bit more performant to have a function which just runs continuously and then pauses itself and then starts back up again after a specified amount of time, versus having an update function which gets called every frame and then has to do a comparison with an if statement. It's better to have a function that's continuously running than to have a function which has to start, do an if statement comparison, and then stop. So that's why we're going to use this I enumerator. 1 for the performance, and then 2 for the fact that it's just a bit easier to understand. So now that we understand coroutines, let's go ahead and delete this line right here. And what I'm going to do is make that while true block so that this function just kind of runs over and over. And then I'm going to add a yield return, and I'm going to say rotate pause. So we're going to make this new variable right here. And we'll declare it at the top of the script. We'll say private, and it's a wait for seconds type. And we'll call it rotate pause. And we'll say is equal to a new wait for seconds. And I think 0.8 seconds would be a good pause between rotations. And I'm just basing that off of the footage from the game. And now what we need to do is figure out how to actually rotate this thing. So we can decide whether we want to use transform.Rotate, which uses Euler angles, or we can use transform.Rotation, which uses quaternions. So I'm going to quickly go through and explain what these are. So if you're already familiar with rotate and rotation and quaternions, you can skip through and go back to where I'm working on the script again. But for everyone else, I'm going to go through this table and quickly talk about what these are. So the main difference between rotate and rotation, in my opinion, is that rotate uses Euler angles, which we usually pass in as a vector 3, and transform.rotation uses quaternions, which are a bit more difficult to understand. So here's a script that generates, well, it doesn't generate, it spins a cube around. And the way it works is we create this angle, which is a vector 3, and we have nothing in x and z, and then we have 0.5 degrees in the y. And then all we do is in the update function, we write transform.rotate, and then we pass in this angle, which is 0.5 degrees around the y-axis, and then every frame it's going to rotate by that amount, and you can see what it does to this cube. So here's the exact same thing, but with quaternions now. So you can see we still have that vector 3 angle with the 0.5 degrees, but now we have this quaternion angle, and it takes in the vector 3 and then passes it into this quaternion.Euler method. And basically that just takes Euler angles and turns them into a quaternion. And then in the update function, we have this quaternion new angle that multiplies whatever the rotation is at that frame by the quaternion angle, and then it sets the transform.rotation equal to that new angle. And you can see that it basically spins the cube in the exact same way. All right, so that's the Euler angles and quaternions part of it. But next, transform.rotate is a method. So maybe you notice that when we use it, we actually pass an input into rotate versus transform.rotation, which is a property. So we set it equal to a value. And we can also use it in equations, like I multiplied by transform.rotation. And that's because it's a property, not a method. So in the example I just showed, both rotate and rotation were doing the exact same thing, but typically rotate is used to nudge an object by a certain angle, which is what we were doing with that spinning yellow cube. We were just nudging it around the y-axis by 0.5 degrees every frame. But transform.rotation is usually not used that way. It's actually used to set an object to a specific rotation. So let's see what I mean by that. So let's look at another scene I set up where we have that same yellow monkey, and now there's a red ball in the scene. And you can see that no matter where I move the red ball, the monkey stays staring at it. And this is achieved using quaternions. So here's the script for that scene. And we have the public transform red ball, which is just the red ball from the scene. We have vector 3 position difference and quaternion look direction. So in the update function, every frame, we're setting position difference equal to red ball dot position minus transform dot position. So you can think of this as a vector 3 that points from the monkey to the ball's position. And then we have this quaternion look direction, and we're setting that equal to quaternion dot look rotation position difference. And all this is really doing is turning that vector 3 into a quaternion. So it's using that vector 3 to set a specific rotation. And then lastly, we set transform.rotation equal to the look direction. So we're setting the rotation directly equal to that quaternion, which is pointing towards the red ball. So this happens every frame, and then the result is that the monkey stays fixed to the red ball no matter where we move it. And the final difference is that transform.rotate is easy to use, in my opinion, while transform.rotation is a bit more complicated. And that extra complication comes from the fact that it uses quaternions, which are more difficult to wrap your head around than Euler angles, and also require the use of a new data type with its own methods and properties. So for that reason, we're actually going to use transform.rotate to rotate the gears, even though we could also do it with transform.rotation. Okay, let's actually write this thing. So what I'm going to do is in the Unity editor, I'm going to click on portal gear, the one in the front, and I'm just going to pop this script onto that gear. And then let's go into VS Code. And then, so here's where we left it. And what we want is actually another while block. And you'll see why in a bit. So I'm going to write while. And then for now, I'm just going to leave this as something. We'll worry about that later. And then what we want is in this while block to rotate the transform and then pause for a frame and then start the while block over. So to pause for a frame, we can write yield return null. That just pauses for one frame. And then I'm going to write transform.Rotate, and this is the method, so we're going to pass in the vector 3. And I'm going to write new vector 3, and then we need to pass something in to rotate around the x-axis. So I'm going to do something small. Let's try 0.2f, just a float, and then 0, 0 for the other axes, and then end that with a semicolon. And then we want this to rotate around 30 degrees. It seems like that's what they do in the actual game. So what I'm going to do is create a variable to hold that amount. So I'm going to write private float, and let's say rotation amount is equal to 30 degrees as a float. And then what we can do is every time this thing rotates, we can subtract off that 0.2. So what I'm going to do is say rotation amount is equal to, oh no, here's what I'm going to do. I'm going to make a variable right here, and it's going to be a float, and it's going to be degrees left, and then I'm going to set that equal to the rotation amount. So every time this while true block runs, this thing is going to be set equal to 30 degrees, and then I'm going to say while degrees left is greater than 0, then this thing is going to run, and then every time we run it, degrees left is going to decrease by the amount that we rotate, which is at 0.2f, right? So what's going to happen is the transform is going to rotate, degrees left is going to decrease, we're going to pause for a frame, and then we're going to check how many degrees left we have to rotate. So once all 30 degrees are up, then we stop this while block, we pause for the pause amount, 0.8 seconds, and then we start the whole thing over again. So back in Unity, nothing's going to happen because we need to press play for the script to run. So I press play, and let's see. Rotates 30 degrees, and then it pauses. So that's kind of what we want, except it's going pretty quickly here. So what should we do about that? So back in our script, what we could do obviously is just decrease that 0.2f to a smaller value until we get something we like. But there is a problem with this script that I'm sure some of you noticed, and that is if the frame rate of our game changes, then this gear is actually going to be rotating at a different amount because we're pausing for a frame and then rotating by a set amount. So if the frame rate is say 30 FPS, the gear will rotate a smaller amount compared to if the gear was running the game at 60 FPS because there's going to be more frames called in the same amount of time. So what we're going to do is actually use Time.deltaTime, and if you already know how this works, then you can go ahead and skip my long-winded explanation I'm about to go into. But for everyone else, let's see what Time.deltaTime is. Time.deltaTime is really just the amount of time that elapses between frames being rendered in your game. So if your game is running at 30 FPS, Time.deltaTime is just going to be the inverse 1 over 30. Whereas if your game is running at 15 FPS, then Time.deltaTime is going to be twice as big. It's going to be 1 over 15. So as frame rate decreases, Time.deltaTime increases. So let's look at an example with some code running inside the update function that does not use Time.deltaTime. So we set angle equal to this new vector 3, which could represent a rotation of 6 degrees around the y-axis. And we say transform.Rotate by the angle every time update is called, which is just going to be once per frame. So let's look at what happens after 1 second elapses, and each of those bars down there represents 1 frame of the game. So after 1 second, the arrow is going to rotate by 180 degrees, and that's because it rotates 6 degrees every time a frame is called, and the frame gets called 30 times. So let's look at what happens when the game is running at 15 FPS. So again, we have this arrow at the start, the same code, but now there's half as many frames because the game is running at half the frame rate. So where do you think the arrow is going to end up after 1 second elapses? It's going to be at 90 degrees because we rotate 6 degrees per frame times 15 frames, and that's 90. So in the same amount of time, the arrow has rotated half the amount. So it's almost like our speed has decreased by half. So how can we get around this? Well, here's some new code. And instead of writing 6, we write 180 times time.deltaTime. So if time.deltaTime is 1 over 30, then our angle of rotation, that degree, is going to be 6. Whereas if our frame rate is 15, it's going to be 12. It's going to be twice as big. So that means if our frame rate goes down, then our speed of rotation goes up in exactly the amount we need to compensate for the drop in speed. So I don't even need to have two different slides here, because whether it's at 30 FPS or 15 FPS, the rotation is going to be the exact same. So you can see that down there, 180 times time.deltaTime at 30 FPS is 6, and 180 times time.deltaTime at 15 FPS is 12. So we have this corresponding increase in rotation amount when we have a decrease in frame rate. So that makes sure that in the same amount of time, the arrow ends up in the same place. So back in our script, what do we need to do? Well, for one thing, I'm actually going to move degrees left up here, just so we don't keep declaring it over and over. Degrees left. And I'll just leave it uninitialized right there. And what I'm also going to do is add a rotation speed. Rotation speed. And I tinkered around with this a little bit, and I'm going to set it at 35.0. That seems like a good speed compared to the actual game. And what do we need to do now? Well, what I'm going to do is actually make another variable. I'm going to say private float this rotation. And this is going to represent the amount we need to rotate every time this while loop is called. So I'm going to add a line right here that says this rotation is equal to, and I'm going to say time.deltaTime. And then I'm going to say, I'm going to multiply that on to the rotation speed like that. And then I'm going to copy this, and I'm going to put that into our vector 3. So every time this while loop is called, it's going to be once per frame. We're going to rotate by this rotation amount, which is actually changing based on the frame rate, based on time.deltaTime. And then we actually need to decrease degrees left by however much we rotated. So let's go ahead and do that there. Degrees left minus equal this rotation. And let's see what we get in Unity. So this looks pretty good, but there is one problem, and that is that this gear isn't actually going to be rotating perfectly by 30 degrees every time because of the way that we've coded this while loop logic. So let's go back to the code and see how we can fix that. All right, so you may have already spotted what the problem is, but if this rotation, this variable right here, is changing, it's not going to be the same every time, then the amount that we rotate might be different after every pause. In other words, sometimes it might rotate at 29 degrees, sometimes it might be 31 degrees, because we don't know for sure what this rotation is going to be. So to do that, we actually need to have some clever code in here, and we're going to do math.min. I think it looks like that. Yeah, like that. And then we're going to surround this. And so math.min is going to choose between this, and it's going to choose between degrees left. So this ensures that we always hit 0 when the rotation needs to stop. And it might be kind of tricky to see why that is, but I want you to go through your head some examples of when math.min might choose this side or when it might choose this side. And you'll see that it should always pick the amount that will lead degrees left to be 0. And that's going to make it so that we rotate perfectly by 30 degrees every time. So let's go back to Unity and check it out. So here we are in Unity, and I just have the gear selected in the inspector. And you can see that when we rotate, it goes exactly by 30 degrees every single time. And so that's what we want. And then the next thing we want to take care of is the game doesn't actually look like this. It doesn't like perfectly start and stop the rotation. There's almost like a little kind of nudge in the gear when it gets started and when it's stopped. And it makes it look kind of mechanical. It looks pretty cool. So let's see if we can replicate that in the code. Okay, so what do we need to do here? Well, first of all, I'm going to set the nudge amount to be 3 degrees. That looks pretty good to me. So I'm just going to write nudge amount. I'm going to say 3.0f. And let's see. Oh yeah, let me get rid of this float too. We don't need that anymore. So what we want to do is actually just copy paste this block right here. This entire thing, and then we'll put it right at the top of this kind of outer loop. So degrees left is going to now equal nudge amount, because we want to do 3 degrees. And then we're going to keep this logic the same. This rotation is going to be the same. So the speed's going to be the same. It's just going to stop as soon as it hits that 3 degrees. And then obviously it's going to be going in the opposite direction. So we're going to put a negative right here. So that's going to make sure it nudges to the right, and then it goes back to the left for the rotation. But there's a problem here because this is only rotating by 30 degrees. So if we want it to make up for the nudges, what we're going to do is actually add 2 times nudge amount. So this rotation here is actually going to be 36 degrees now. So you can think of it as this rotation puts us at -3. This puts us at +33. So then we need one more nudge to put us right back at 30. So let's do that here. So degrees left, again, is going to be nudge amount. And then while it's greater than 0, this rotation is blah, blah, blah. And then this rotation should be negative again. And then that looks pretty good. So let's save it and go back to Unity and see what we get. And there we have it. It looks like it's nudging pretty cool, and it looks all like mechanical and stuff, like it looks in the game. So yeah, it looks pretty good. Let's go ahead and put this on all of the gears and see what happens. So I'm going to select all of the inner gears here in the editor, and then just drag this onto them in one swoop. And let's press play and see what happens. Yeah, that looks pretty good. Honestly, that looks pretty cool. Yeah, so that's the rotation portion of this video, and that's all done and squared away. And now what we're going to do is work on the sort of like animation thing where the gears pop in one at a time. And then there's also this sort of fade to the gear color as they go back, and it makes it look like there's sort of like a decreasing light source. So let's work on that now. All right, so to make that sort of like darkening fade effect as the gears go backwards, we're actually going to go into that shader again and create a new property, which we can then change from a script. And I went and grabbed that inner gear material again so we can see what happens. So let's go back inside the shader code, and we're going to add a new property called fade, and we'll just call it fade in the editor. And it's going to be a range, which is like a slider. It'll go from 0 to 1, and then we'll start it off at 1. Actually, we don't need parentheses there, I think, so we'll just say 1. And then I'm going to copy that and go down here, and we're going to declare it as fade, a float. And then we're just going to multiply that onto that final color. So as it gets towards 0, the color is going to get darker, and as it gets towards 1, it's going to be that original blue tint that we had. So back in Unity, we can see that nothing changed, but if I click on the material, and then you can see we have this little slider here now. So I can drag it between 0 and 1, and you can see that the gears get darker and lighter. And so we want the gears in the front to be super light, and then the ones in the back are going to be dark like this. So we're going to have to make a new script to do that. All right, so now that that's done, what we need is some kind of object to manage all of the gears at the same time. And we're going to call that object a manager. So what I'm going to do is create an empty right here, and I'm going to make this called gear manager. And I'm just going to put it right here on top of those gears. And then we can also create a new C# script, and I'm also going to call that gear manager. And what we want is for this gear manager to have access to all these gears. So if we go in this code, we can go ahead and delete the update function. We don't need that. And in order to access these gears, we need to have them available in like a list or an array or something like that. So I'm going to use a public array. because I think that's one of the most convenient ways to do it. And the declaration looks like this, and I'll just call it gears. So now we have this array of game objects called gears, and it's public, which means we can access it in the editor. So if we Control S and go back to Unity, we can put this script onto the gear manager. And you can see that there's this empty list right here with gears. So I'm going to lock this in the inspector so it doesn't move. And then I'm going to grab all of these gears and I'm just going to pop them right into the list. And now you can see they're all on the list, which means we can actually access them from the script. So if I go back to the script now, we need a way to iterate through the array. So to do that, we're going to use a for loop, and you construct that like this. So for int I is equal to 0, I less than gears dot length, and I plus plus. And then we're going to make a code block. So if you've never seen this before, a for loop just kind of iterates over and over as many times as I satisfies this condition right here. And so really it's just going to loop through all of the indices of this gears array to access every single gear. And to access them, you would write something like gears and then square brackets and then I, like that. But we don't just want the gears game object. We actually want the renderer of the game object. So I'm going to make another variable up here. It's going to be a renderer type, and I'm going to call it gear renderer. All right, so I'm going to copy paste that, and I'm going to set it equal to the game object dot get component, and then I'm going to make these angular brackets, and I'm going to say renderer. And then add some parentheses. And then that's actually going to grab the renderer, which is kind of like the material of the game object. So then what I can do with that is write gear renderer dot material. And then now I'm going to write set float. And this is a special method that allows you to access variables that are inside the shader. And then all I have to do is supply the name, which is fade. And then I'm going to set the value to 0.5f so we can see what happens when we change this value. So we're back in Unity, and let's see what happens when we run that script. It's a little hard to tell, but the gears have all darkened, and you should be able to notice that because of how different it looks from when we don't activate the script. So what's going on is the script is accessing this material right here that's on all the gears. Let me get rid of that. And it's changing this fade value for each one. So what we really want is to have a different value for each gear, where the values in front are lighter and the values in the back are darker. And we can do that by using the index of the gear inside the array, because they all have a different index, and the ones in the front are very low and the ones in the back are very high. So we can use that to our advantage to change the fade value differently. So what we can do is create another variable, and we'll call this fade value, and we'll make it a float. And what we're going to do is, we're going to base it off the value of I. So I can say fade value is equal to maybe something like I divided by 11, since there's 11 gears. So when I is 0, it's going to be 0, and when it goes up to 11, it's going to be 1. The problem with this is that the gear in the front has the value 0, so that's actually going to have the lowest fade value, so the gears are going to get brighter as they go backwards, which obviously is not what we want. So instead we can do 11 minus I, so now it's kind of like I is reversed. And let's go back to Unity and see what that looks like. So if I hit play, let's see. Yeah, nothing changed. I wonder why that is. Oh, yeah, because we didn't do anything with fade value. We just kind of left it there. So I'm going to put fade value right there and go back to Unity. And I'm going to hit play. And they are completely dark in the back. I wonder why that is. Let's see. So Okay, yeah, the problem here is we're actually doing integer division right here, which basically cuts off the decimal, so we're going straight from 1 to 0, which obviously is not what we want. So I'm going to make this a float. And if we go back to Unity, let's see what happens. There we go. Yeah, it kind of gets darker as it goes back, and then I think it's not getting dark enough or as quickly as we might want. So I'm actually going to go back to the script, and I'm going to do something a little bit weird here. I'm going to do math f.pow. I'm going to make some parentheses, and I'm going to put a 2 right here. So what this is going to do is basically square every fade value that we have, which means as it gets closer to 0, the differences between the gears are going to become more pronounced. And to compensate for that, I'm going to change this to a 9, just because I think that'll look a little bit better. So let's see what that looks like. Yeah, I think that looks pretty good. So it gets darker, but it seems like it gets darker faster as you get towards the end, which is a bit more what you'd expect light to behave like. So I'm going to leave it like that. Okay, so the last thing we need to do is make it so the gears spawn in one at a time from the very beginning. And so what we need to do here actually is to turn the gears off, in a sense, like make it so they're not drawn to the screen. So since we already have the renderer here, all we have to do is set it to false. And I've been working with Python too much. That's supposed to be a lowercase f. And so when we start the scene, the gears are actually not going to draw to the screen. So to turn them on, we need something that can turn the gears on one at a time and also pause in between. So we're going to use another coroutine for that. So I'm going to do start coroutine, and then I'll call it spawn gears with some parentheses there. And then let's go ahead and make that function down here. So it's enumerator spawn gears, and then we can write the code in here. And we're going to put all of this inside another for loop, I think. But this time we want to go from back to front instead of front to back. So we're going to write int I is equal to gears.length -1. That's going to start at index 10 since there's 11 gears. And then we're going to do I is greater than or equal to 0. So once I hits -1, we're going to stop. And then I minus minus, which is going to decrease I by 1 for every iteration of the for loop. And then let's see, what do we need to do here? We need to grab the renderer again. So I'm just going to copy this line right here. And then all we need to do is say dot enabled is equal to true. And that should turn the gear back on. And we also need to yield return for the pause. And let's see, might need to play around with this. So let's create a private wait for seconds equals new wait for seconds. And I don't know how long this needs to be. Let's try maybe 0.2 seconds. Oh yeah, we need a name for this. Let's do spawn pause. All right, let me copy paste this, and then we'll just return that at the end. And let's see what that gives us. All right, so let's hit play. And that looks pretty cool, but it's also a little bit too fast. So let's go back to VS Code, and we're going to change this to a 0.4. And what else? So I think the first gear spawns as soon as we start the scene. So I'm actually going to move this yield return right above the enabled equals true. So that's going to give us the same spacing between the gears. But the first one is going to take a little bit longer, so hopefully we can catch it. So let's try it again. All right, yeah, I think that looks pretty cool. It looks pretty accurate to the game too, so I'm going to say that we're finished here. So if you made it through the entire video, you just modeled your own assets, you wrote the shaders to render them in Unity, and you made the controllers to animate them. So if you made it this far, you should feel pretty proud of yourself. And I think that's it from me, so I hope you'll see me in the next video.